Okay, so now that we know what the trigonometry functions actually mean, that these are ratios, we can use those ratios to help us solve problems. So before we even start, remember our mnemonic to help us remember which trigonometric function represents which ratio is SOHCAHTOA. So remember SOHCAHTOA. And remember, this is just to help us remember which sine function is the name of which ratio. So that's saying if you write the sine of a specific angle, that means for that angle, whatever it is, sine of that angle tells you the ratio between the opposite side and the hypotenuse for that angle. And let me just move these over here so I have a little more space. For cosine of an angle, this tells you the ratio of the adjacent side to the hypotenuse. And then the last one, TOA, is for the third trigonometric ratio that we're using, which is called tangent. So the tangent of a specific angle means the ratio between the opposite side and the adjacent side. So you can see here, SOHCAHTOA, the S is for sine, the O is for opposite, the H is for hypotenuse. Same with CA, C is for cosine, A is for adjacent, H is for hypotenuse, and TOA, T is for tan, O is for opposite, A is for adjacent. So this is a mnemonic to help you remember. I would definitely have it somewhere in your notes, but after a while, when you do it more than once, you'll get to, you'll probably start remembering, and it's a little bit faster when you can just do it from memory. But until then, you can hang on to your notes. So great, so SOHCAHTOA. So these are the ratios we're going to use to help us solve a question. So a question you might get would be something like this. So you'd get a right triangle, and the question would show you this symbol. Remember, this symbol means that that's a right angle, meaning that's a 90-degree angle. And remember, these ratios we're using here, the way we're using them right now, it only works for right triangles. Only works for right angle triangles. So the ones that have a 90-degree angle. Okay, so you would get a question like this. They'd show you a setup like this, and then they would say this angle equals 21 degrees. And we know that the hypotenuse is, let's say, 12 feet. And then they'd say, we want to figure out how tall this triangle is. So when you are solving for the missing side of a right triangle, step one is to label the sides of the triangle as like opposite, adjacent, hypotenuse, opposite, adjacent, hypotenuse, in reference to the angle given. And that's not the right angle, because every single right triangle has a right angle, and we can only use our trigonometric functions with ones that are not that right angle. So not the right, which means 90-degree angle. You want to do it with the correct angle, not the right angle. Okay, so that's step one. So up here, let's do that. So the angle they gave us is this 21-degree angle. And I just draw this little symbol. Whenever you see an angle anywhere and it has this symbol, it just means they're showing you that if I label this 21 degrees, it's going from here to here. So it's the angle between those two parts. That's important because you might get a question later where there's two angles labeled. So it might look something like this. And they would go like this and show you, okay, this one is our 40 degree. And then they'd show you this one is the 32 degree. So that's why they have those. It's just to show you which angle they're talking about. So that explains that symbol. So we still haven't done the first step. So it's label the sides of the triangle as opposite, adjacent, hypotenuse in reference to the angle given. And that's not in reference to the right angle. So they gave us this 21 degree angle. And remember, the hypotenuse is always, always, always the one across from the right angle. It's the longest side. So that's definitely the hypotenuse. And then for this side and this side, we look at this 21 degree angle, and we see that the side where I wrote our question mark is across from or opposite the 21 degree angle. So that's our opposite side. And this side down here is adjacent or next to that 21 degree angle. So that's our adjacent side. Okay. So then the next step is we take this question right here and we we figure out which trigonometric ratio so that's like sine, cosine, or tangent will be most helpful to us here. Will be most helpful to us because we're going to use them to help us figure something out. So what we do is two things. We think about, or actually I'll do this up here. So think about side, oops, you already know, and the side you want to find. So for this question, the side we already know is I gave you the length of the hypotenuse. So you already know the hypotenuse. And I asked you for this side. So you're looking for the opposite. So in this case, you are looking for the opposite and you have the hypotenuse. So we're going to use that to figure out, okay, which ratio would be most useful for us. So we look at our ratios and we see which one uses opposite and hypotenuse. So in SOHCAHTOA, you can see that sine is the one that uses opposite and hypotenuse. Okay, so now we set up an equation. So the way we're going to do this is we're going to say the sine of 21 degrees. So remember, that's the angle I gave you. And what's sine of 21 degrees? It's a number. And you can find it. And what it really means is that for any triangle, any right triangle where one corner has a 20 degree angle, the side opposite that 21 degree angle divided by the hypotenuse is going to have a consistent ratio. No matter how big or small that triangle is, because it has that specific angle, those sides are going to be in a specific ratio. So this answer right here, sine of 21 degrees, we can do it on a calculator. So if we do that right here, so let me just clear some things out here. Okay, so remember I said it's important that your calculator is in degrees, so make sure that you can see the letter D up at top. And so sine, if you type in sine of 21 degrees, and just to clarify, what I'm doing right here is this screen right here is just a blown up version of this small screen on my calculator so you can see it better. And this one on the top is showing each button that I push in the order that I push it. Okay, so sine of 21 equals, and if we do that, that answer right there, 0.35836799495, that is the ratio of the opposite side to the hypotenuse side for every single triangle, right triangle that has a 21-degree angle. So what we can do is we can say, okay, no matter what size ours is, this ratio is going to be true. So that means that if we go back to our problem here, let me just go back really quickly. Okay, so if we go back to our question, this sine of 21, remember that was a ratio, we just found it. We said that it was 0.35836799495. So that ratio right there, no matter how big our triangle is, because it's this exact shape, it has that exact angle, when we do the ratio of its opposite side to its hypotenuse, it's going to equal that number. So that helps us figure out the thing we don't know, because if we set this up, well, we went back up here. Okay, here, maybe I'll move this whole thing up here. Oh, no, I'll keep this here. So when we went back up, our hypotenuse, we knew that was 12 feet. And our opposite side, that's the side we didn't know. So remember here, we had 12 feet, but we didn't know our opposite side. So you could write the word opposite, you could write a variable, like maybe P to represent it if you want, X, whatever you like. So we don't know it. But we know that whatever that side is, when you divide it by its hypotenuse, you're going to get this ratio. So whatever P is, divided by 12 equals this number. So this means we have an equation, and now we just use algebra to solve. So so step 4 is use algebra to solve for the missing, or to solve for the variable, or the missing side, which now I've written as a variable here. So if this is our equation right here, 0.35836799495 equals P over 12. I just copied it down. We need to get the P on its own. So right now P is being divided by 12, so we do the opposite of that, and we multiply both sides by 12. And on this side, on the right-hand side, they cancel out, and we're left with just P. That's good. That's what we wanted to do. And on the left-hand side of the equation, we have this big, long number times 12. Now, important, I'm going to show you 2 different ways of doing this to make it easier. But if you still had that number in your calculator, so if you still had this number and you just hit times 12, you see that this ANS button pops up, and ANS stands for answer, and that means that your calculator just put in the last answer you got, and then you can multiply by 12, and that way we didn't have to type it all in. So we get 4.3004. So this means that our answer is 4.3, and originally that was feet. So what I would, I was supposed to say feet, there we go. So what I would do now is just think, okay, does this make sense? So that's the last step, is think, does your answer make sense? Because if you make a mistake and you accidentally switch something, your answer that you get probably won't make much sense. So this is a good, quick way of checking your answer. So it's a good way of checking your answer. Okay, so does this answer make sense? We go back up and look at our triangle. So originally, the hypotenuse we were given was 12 feet, and we found that this opposite side, it was 4.3 feet. So that seems to make sense. It would have been really weird if we had gotten like 50 feet. We would have said, well, that's clearly wrong, because if this longest side in the triangle is 12 feet, then that's not going to be 50. Even if we'd gotten maybe like 11 feet, you'd say, well, it's not longer than the hypotenuse. And I know the hypotenuse has to be the longest side, but like looking at this triangle right here, this is definitely the shortest side. I don't think there's any way that this opposite side could be 11 feet. So that would mean you'd done something wrong. So it's a really good way to check your answer by just seeing, okay, does it make sense based on the shape of the triangle? And that's it. That's all the steps. So I'm going to do one more example of a question kind of like that. And then we're going to move on to just the same thing, but just sometimes the algebra is a little bit harder. So we'll do one with a harder algebra example. So this is our example 2. So what I would do is I would follow along on a piece of paper. So example 2. Okay, and let's say this is, nope, I'm not gonna do this one, I lied. Let's say this, okay, let me redraw this whole triangle. Sorry, guys. Okay, that's even worse, but all right, something like that. And let's say this one up here we have is 59 degrees. And let's say I gave you this up and down side, and I said, okay, from here, from this up and down side is 6 inches, and I said I wanted to know this bottom side here. So remember, our first step is always label the sides of the triangle as opposite, adjacent, hypotenuse in reference to, in relation to the angle given. So the angle I gave you was this top angle up here, this 59 degrees. So we're going to label this triangle in relation to that angle. So remember, across from the 90-degree angle is always, always, always the hypotenuse. So that one's easy. And then we look and we see, okay, this one opposite the 59-degree angle is the opposite side. And then this one next to or adjacent the angle, but that's not the hypotenuse, is our adjacent side. So now we have our sides labeled. Excellent. Okay, step 2, remember, is figure out which trigonometric ratio, sine, cosine, or tangent, would be the most useful to us. We have to think about the side we already know and the side we want to find. So I'm just going to rewrite SOHCAHTOA to help us out. SOHCAHTOA. So we think about, okay, the side we want to know is the opposite side. And the side we already have this time is the adjacent side. So what we do is we go through SOHCAHTOA and see, okay, which one of those has opposite and adjacent. So it's TOA, which is tangent. So remember, this is written in order. So this means that the tangent of an angle is just the name we give for the ratio between a triangle's opposite and adjacent sides for a specific given angle. So, okay, we figured out we're going to need tan or tangent. So then our next step is set up an equation. So this means, okay, for any angle in a triangle that's 59 degrees, this, when we put this in our calculator, that will tell us what the ratio is, what that consistent ratio is for any angle in a triangle that's 59 degrees. No matter how big or small that triangle is, it'll be the same ratio. Equals, and that is, remember, we just said that's the ratio between its opposite and its adjacent sides. So what I'm going to do is plug in the stuff we do know and the stuff we don't know. So here, we didn't know the opposite side. This time I'm going to call it x just for fun. So let's say x, I'm going to put that where our opposite side goes because it's the one we don't know. And then we did know the adjacent side. I gave it to you. I said it was 6 inches. So I'm going to put 6 here. So now when we put this tangent of 59 in our calculator, it will give us the ratio between the opposite and the adjacent side for a 59-degree angle. And whatever that number is, it's going to equal our unknown side divided by our adjacent side of 6. So last time I entered the trig into my calculator right away to get an exact number. And I could do that. So if I wanted to, I could say, let me just get rid of some things here. I could do tangent of 50, what did I say? 59 degrees. So tangent of 59 degrees. And I would get, okay, that ratio equals 1.6642. But sometimes when I am doing a question like this, I will actually leave that until the end just because it is a really long decimal to write out. So instead of solving this first, instead of figuring out what that ratio is first from my calculator, I'll do the algebra first just so that I don't have to keep writing down that long number. It's up to you. Whatever way you find easiest is how you should do it. So I'm going to do it this way this time just so you can see both ways. So now we have this. So remember, our next step is to solve for our unknown using algebra. So this is going to end up being a number that we do know. I just am leaving it for now so that I don't have to write down that long decimal ratio. But then we need to get this x on its own. So we're going to multiply both sides by 6 because right now x is being divided by 6. We have to do the opposite. So now I am left with x on one side, which is great. That's going to give us our opposite side. And on this side, I have 6 times tan 59, which is going to be 6 times the ratio that is the opposite to the adjacent for a 59-degree angle. So now in your calculator, you could enter all of that at the same time if you wanted. So you can go to your calculator and let's say we do this. We could put in 6 times tangent of 59 degrees equals, and it has done all of the math for us. So it's 9.985. I'll round that to 9.99. So our answer then is that this opposite side is 9.99 inches, or almost 10 inches. That I didn't give you like a round to however many decimal places instruction, so you can round to something that seems reasonable. So 9.99 inches. Then remember, our last step is, does our answer make sense? So if we look at this original triangle, we saw that the side I gave you, the adjacent side, was definitely the shortest side. So we'd expect that our answer would be longer. But it's maybe not the longest side because that's clearly the hypotenuse. Hypotenuse is always the longest. But like about 10 inches seems to make sense. I mean, it definitely wouldn't have made sense if I got like 5 inches or 6 inches. It probably wouldn't have made sense if I got like 20 inches because that really doesn't look like 20 inches in comparison to the 6. So about 10 inches seems to make sense. So we are all done there. Done. Easy. So the only time this can get more complicated is just when the algebra requires more than one step. Sorry, that's my mother. I'm going to hang up on her. Or maybe yes, I am going to answer. Sorry about that. So this is an example of when your algebra is just a 2-step rather than just 1 step. That's all that is more complicated here. Otherwise, it's the exact same thing. So in this question, you have one angle that's given, one side that's given. We have a right angle triangle, and I just said find x, round your answer to 1 decimal place. So we're going to follow all the same steps. So remember, our first step is always, always, always label the sides of the triangle in relation to this given angle of 70 degrees. So remember, the side that's across from the right angle is always the hypotenuse, so we know that one first. And then on the side opposite that 70-degree angle is the opposite side. And the side adjacent to the 70-degree angle is the adjacent side. Okay, so we have labeled those. Now we need to figure out which of the three trig functions do we need. So remember, so, ka, to. So we think about, okay, which side are we looking for? So we're looking for x, which is our hypotenuse side, and we have the adjacent side. So we need to look for something that has hypotenuse and adjacent. So that is cosine, which has adjacent and hypotenuse. So then we just set up our equation here. So we say that the cosine of 70 degrees is going to be, that number is going to, when we put that in our calculator, it's going to tell us the ratio between the adjacent side and the hypotenuse. And then remember, we fill in the stuff we know. So here we were told our adjacent side is 3.2 meters, and our hypotenuse side they just called x, or I just called x. So hang on here, close, thank you. So now we fill in, okay, so cosine of 70 degrees, that'll give us that ratio. And that ratio is going to equal 3.2, our adjacent side, divided by x, our hypotenuse side. So we set it up exactly like before. And remember, when we put cosine of 70 degrees in our calculator, it's going to give us a number, a ratio, that's going to equal 3.2 divided by whatever our hypotenuse is. So now the only difference here is that this time our unknown is in the denominator. So this time our unknown is in the denominator. And that means if you are really confident with algebra, maybe you've already solved it. If you need a little bit of review, what we need to do is we need to move the denominator first, always. So even though denominator first. So even though we are looking for x, we can't, if we divided both sides by 3.2, we could. I mean, if you divide both sides by 3.2, you could do that, and over here you would get cosine of 70 degrees divided by 3.2. But over here, x would still be in the denominator, so now your answer would say 1 over x. So that's not very helpful at all, because we're not looking for 1 over x, we're looking for x. So what we're going to do is we're going to move that x first. So we're going to multiply both sides by x. So I take this whole side and I multiply it by x. That is 3.2 times x divided by x. These guys cancel out. Then on this side, I'm going to take this whole side and I'm going to multiply it by x. So now I have x times cosine of 70 degrees equals 3.2. So now I can get x on its own by dividing both sides by cosine of 70 degrees. Again, I could have figured out this cosine of 70 degrees number first. I just like to leave it written as cosine of 70 degrees because it's going to be a long number, a long like decimal from our calculator, and I would prefer to not write it down, and so I usually just save it. But if you had already figured out that ratio by asking your calculator to give it to you by putting in cosine of 70 degrees, then that's totally fine. So on the left-hand side here, we had x times cosine of 70 divided by cosine of 70. They cancel out. And so on this left-hand side, we are left just with x. And on the right-hand side, we have 3.2 divided by cosine of 70 degrees. And I can actually plug all of this into my calculator in one step. I'm going to show you how to do that. So now okay, great. So we're going to say 3.2 divided by, and you just type in cosine of 70 degrees. and it does all of that for you. And that way I didn't have to type in that long decimal. I didn't have to keep writing it down. That's why I left it to cosine of, or that's why I left it as written as cosine of 70. And so, but that's our answer, 9.356. And I said round to 1 decimal place. So 9.35. If it's a 5, we're going to round up to 9.4. So now we have x equals 9.4, and I think our original unit was, it was meters, so x equals 9.4 meters. So our final check is just, does that make sense? So we go up and we see, okay, this is 3.2 meters, and this, well, yeah, it should definitely be longer. So 9.4 seems to make sense, makes sense to me. And there we go. So that is just what you do when the algebra is 2 steps. I'm going to show one more example, but if you don't want to see the other example, you can turn off the video now and just go on to the practice. But I'll show one more example of what it's like when you have a 2-step with algebra. So example 4. Okay, so you can draw this right triangle with me. Okay, I'm going to put a 60 degrees in this corner. This is our right angle. And this is going to be it's going to be 3 feet, and then this is going to be x. Okay, so let's say I said find x. I'll give you the same directions. Find x around 1 to 1 decimal place. Great. So same steps as always. First thing we do is label the triangle as opposite adjacent hypotenuse in reference to this angle we were given. So in reference to this 60-degree angle, we're going to label, okay, the one that's across from the right angle, that's always the hypotenuse. And then we're going to label, okay, which one is adjacent that's 60 degrees? So adjacent to our 60-degree angle is this x side here. And opposite that 60-degree angle across from is the side that we were told is 3 feet. So that's our opposite side. Okay, so that was our first step, done. Then we need to think about which of the 3 equations or which of the 3 trig ratios would be most useful to us. So SOHCAHTOA, to help us remember. So we think about, okay, what do we have? So we have the opposite side. And what do we need? Okay, we need the adjacent side. So we look for one that uses opposite and adjacent. Okay, so tangent describes the ratio between the opposite side and the adjacent side for a specific angle. So now we say, okay, so the tangent of an angle, just to remember, I'm just going to write down like a general so I don't forget, is equal to the opposite over the adjacent. So this is just showing, okay, when you put in your calculator tan of a specific angle, it gives you the ratio of the opposite side to the adjacent side for that specific angle. So now that we have this, we're going to fill in, okay, what do we have out of this part? So what do we have? We have the angle. So tan of, okay, we have 60 degrees. And so this is going to give us that ratio that we're looking for, is going to equal the ratio between the opposite side, which we were given, 3 feet, and the adjacent side, which we were not given, we were just told it equals x. So again, this is another situation where to solve this question, the only problem is that our unknown is in the denominator right here. So that's the only difficulty. It just means that we have to do 2 steps in our algebra instead of just 1, because we always have to move that denominator first. So same thing as before, we're going to multiply both sides by x. So times x times x. On the right-hand side of the equation, the 3 times x divided by x, these x's cancel each other out. And so on the left-hand side, we have x times tan 60 degrees, which again, this is a number. I just like to save it for the end because that way, I mean, I could do it right now. If I do in my calculator, tan of 60 degrees, I end up with 1.732 and so on and so forth. So I could do that, but it just seems to me like too much trouble to keep writing down that long decimal. That's why I leave it until the end and I just do it all at the end. So, okay, I digress. So now on the right-hand side, all we have left is that 3, but we still have to solve for x. So our next step, we're going to divide both sides by tangent of 60 degrees. Okay, so on the left-hand side, these cancel out, and we are just left with x. On the right-hand side, we have 3 divided by the ratio tan of 60 degrees. So what we're going to do now is we can just type that exactly into our calculator. So we go to our calculator, and we type in, okay, what is 3 divided by the tangent of 60 degrees? And on my calculator, it gives me, it is exactly the square root of 3. But if this happens on your calculator, you should have a button here on, like mine says S to D, that's standard to decimal form. If you hit that, it'll give you the decimal. So it says 1.732050808. And I said round to 1 decimal place, so our answer is 1.7. So, oops, let me go back to the other screen. Okay, so x equals 1.7, and our original unit was feet. So x equals 1.7 feet. Now all we have to do is check, does that make sense? So we go back up and we see, okay, yeah, this side at the bottom did look shorter than this side. I didn't really draw it perfectly, but it's approximately right. The ones that you see in the book will be nicer because it wasn't me drawing it. And if I give you one, any one I give you on a test or a quiz would be, I'll make it with the computer, so it's perfect. So that's that.